I'm Kendra from Redgate's Advocate Team. And in this talk, I'm going to discuss how you can reduce technical debt with database DevOps. Technical debt, this term, or this metaphor rather, is defined by Martin Fowler in a great blog post on his site, martinfowler.com. And as he explains, this metaphor was coined by Ward Cunningham. The idea of technical debt centers around the fact that it's very natural and very normal and very common when you're making software to sometimes do things that aren't ideal. In order to get things done, we often either don't have the knowledge or we don't have the time to do things, quote, the right way. So we do things that either by accident or just for expediency leave ideal structures or patterns in place that later on we have to work around, and we have to deal with things that weren't optimized from the beginning, things that weren't built to be scalable or perhaps weren't built to be easy to work with. And that's called cruft. When we have cruft in systems, which happens very, very quickly in the real world when we're developing databases, when we're developing software, a key part of this metaphor is that technical debt, you pay interest on that. And the way you pay interest on technical debt is in time. So for instance, if we had a very well thought out database design that was designed to be scalable and easy to work with, then if we had that design, it might take a short time to, let's say we have a new feature, it takes 3 days to work on that feature. But if we don't have that ideal database, and there are things we need to work around, there's extra code we have to write because there's no fast way to do it. We have to test lots of edge cases that may happen because of the way things we can't change quickly. Then let's say that takes an extra day to design this feature, right? Instead of 3 days, it takes 4 days in this case. That extra day that it takes due to that cruft in our database, that is the key part of that technical debt. And that's why we don't just want to let technical debt keep piling up, because then it will take us longer and longer to do anything over time. One of the key issues with technical debt, though, is in the real world, where we're living with a database that isn't ideal. How do we know how much time? How do we measure how much interest we are paying down on that technical debt? Because the thing we can measure is how long is it taking us in reality? We have to estimate or guess at how much of that was time we wouldn't have had to spend if we had paid down some of that technical debt by addressing the cruft in the database, right? We would have to identify the main pieces of cruft that slow us down, that are actually causing things to be slower. So measuring this isn't impossible, but it definitely is tricky and isn't something we can do right away. So what we're going to do in this talk is we're going to talk about 3 things. We're going to talk about how when it comes to the database, cruft in the database doesn't have to stop you from getting started with DevOps, because DevOps can be really helpful at making sure you don't accidentally add to that technical debt using automation, and also for giving you patterns to tackle things incrementally so that as you are prioritizing, hey, which bits of this cruft are actually hurting us the most, you can tackle bits of that over time and then measure how are you improving over time as well. So it helps address not only the pain points of cruft, but it also helps you with that difficult problem of measurement. We want to be able to show when we're doing better, both in terms of code quality and the speed at which we can deploy value to our customers. So one of the big blockers with the database for a while has actually been that databases can have a lot of cruft in them. And sometimes different patterns can block getting the database into version control. Now, having your database in version control is a huge, huge asset in terms of reducing technical debt, because having a database in version control, it is a foundation that allows you to automate, and it also gives you the ability to have lineage of changes. You can know, what is the history of this object? How has it evolved? Where did we mess up? Where did we not mess up, right? So whenever you're trying to fix anything, Version control is a tool we absolutely want to use, but databases can include a lot of non-ideal things, a lot of things that if you were writing code in the beginning, you couldn't even do. For instance, in your production database, you may have invalid objects, right? So here's an example, a customer example, where this customer has been working for a while. This is a legacy database. It's been around a long time. And here's how invalid objects can come about. Let's say 5 years ago, we created 2 tables in the database, right? No big deal. And we also created a view that references those 2 tables. And at the time, people used the view regularly, right? But then things evolved. And the view stopped being necessary. We came up with a different way to do it. Maybe a stored procedure, maybe application logic. But it turns out we didn't use that view in the same way anymore. And one of the tables underneath the view actually got dropped and went away. We did some schema changes. So now we have a view whose definition refers to a table that doesn't exist. If you were to execute the code to create that view and not all of its dependencies existed, that is invalid code. That code will fail. Similarly, you can have cases where objects in one database refer to objects in another database, right? And then they become circular too. The objects in the second database, some of them refer to the first database. So if you get this code into a code base and you're trying to build these databases from scratch, which database do you build first? If database A is dependent on database B and database B is dependent on database A, how do you manage that code in version control? It can be very, very tricky in terms of variety of tooling and having the tooling take in the code and deal with things that are imperfect. Yet, we still need a way to validate code that we are writing, right? We don't want to just say, we don't want to validate code. We have at Redgate a new innovation that helps make sure that having these legacy databases that do have invalid things don't stop you from getting into version control. Because yes, you do want to fix this technical debt, but you want to get it into version control and then iteratively fix it as you prioritize it. You don't want to stop deployments for a long time while you have to fix a bunch of things. So the way in which this example customer fixed this is using SQL clone, Redgate SQL clone, as a baseline. And here is a short demo of how this works. Now, this is a copy of the Stack Overflow database, and I've put some invalid objects in it. So we're going to first run find invalid objects, and we've got one view here that references something in a we don't even have this database here. Maybe this database doesn't even exist anymore. And then the second one is a view that references a table named I existed and I also exist, and they don't. They don't exist anymore. So I've put these into the Stack Overflow schema. They didn't already exist in the Stack Overflow schema. But yet, I've gotten this database into source control using SQL change automation because I've said I want the starting state of the production database to be represented as a clone, a lightweight snapshot. And you can see that I can still make changes to the database and generate, hey, what are the SQL commands that would make this change take place? I could also write my own SQL commands if I wanted to. In this case, I used the GUI and I generated the code for that. So I am able to use a very lightweight snapshot, even if this is a large database, as my starting point and work from there. And this can be accessed not only in creating changes for source control, but in verifying the database, in building the database. SQL change automation is able to say, okay, your starting point, perfect or imperfect, is here. We will put it in place with a clone snapshot, and then we will take all the modifications that you're building on from your starting point and apply it to that snapshot. We can check, we can use version control, we can use Git, just like everything else, and SQL clone manages making us be able to use a development database as well as a shadow database for verification there. Another tool that we can use in addition to this, right? So this was the ability to use technology to say, we're just going to start where we are, imperfect or not, by integrating cloning into our DevOps process with SQL change automation. A second thing you can use is using automation to prevent your debt from ballooning. We don't want to accidentally or purposefully start changing things, right? We don't want to introduce more views that reference invalid tables. And we can do that, right? If we have views that reference tables and we change the tables underneath them, if those views weren't created with schema binding, we can introduce more and more debt. Now, depending on what your goals are, here's an example of a customer who wants to move towards microservices. They have a legacy monolith database that is very active, but they want to move towards eventually having separate databases and use a microservices pattern. They've started moving code into separate schemas in the same databases, but there's still dependencies between the schemas, whether it's foreign keys, whether it's views referencing tables in another schema. So over time, they just want to make sure that the dependencies are either staying the same amount or going down, the cross-schema dependencies. This is able to be solved by automating tests. In this case, we wrote T-SQL t-tests and created static data tables. The static data tables record, here are the existing dependencies at the time we start. So you only have to populate those once. And then automated build check when in the process of saying, hey, I want to do a pull request to merging code, the automated test check, hey, have you added a dependency that's not in that table? If so, the test will stop the build and alert you that, yeah, we don't want to add any more of those into that. So this helps ensure that technical debt doesn't just grow out of control. We also need to prioritize. So we need to make sure we can get started wherever we are. We need to start using automation to make sure we don't add to the technical debt as we're deploying changes. And then we need to look at our existing cruft, our existing technical debt, and start paying it down. But we need to be able to do it gradually so that we don't get stuck, right? So that we don't have to stop releasing changes for a significant amount of time. The big way to do this, the first thing to think about is to look at where your pain is and where significant toil is. Toil being manual tasks or people saying, this isn't, I have to work around this existing problem. And I know there would be a better way to do this if we could optimize X, right? So this is not fixating on minutiae. This is not necessarily we aren't following a best practice. Best practices don't always pay off, right? Some things are a good idea, but implementing them won't actually save you time. One example of this is renaming objects. Yeah, it's not fun to live with things that don't have an ideal name, but how much time does it actually cost you? That's what you want to think about in prioritizing these, right? Just because it's irritating doesn't necessarily mean it's the thing that will help you either have better quality code or move faster or both. Gaining proficiency in your version controlling tools and your automation can really, really help with this. You don't want to write every single T-SQL t-test you could write at one time. You can't. But thinking about, like that case where we want to move towards microservices, think about strategically, what are the big picture items that will help you reduce the technical debt? And what are the automation and tools that will help you do that the most? And prioritize learning about those to gain proficiency there. Our top takeaways from this talk. Technical debt doesn't have to block you. You can get started where you are. Don't feel that you have to fix a bunch of things before you can begin a DevOps transformation. Also, one thing that pairs really well with this is there are ways to incrementally pay down this debt, and almost always that is the way this goes. You want to be able to look at right now, what is the thing to change that will help us move forward, either by establishing a proficiency that will help you make a bunch of progress or by tackling something that is a major pain point. And how can you use automation so that you're not introducing a lot of manual tasks and over time you can simply improve. Automation will also help you look at, okay, where have we had flaws in the past and how can we write tests or design checks in the workflow that remind someone, hey, look at this point and make sure we aren't continuing this bad practice. That could be static code analysis, that could be checklists, but a lot of times there's ways to do this with automation as well. Thanks for joining me for this talk on reducing technical debt with database DevOps. I'm Kendra Little from Redgate's Advocate team.